Did you see this latest report? There's like real controversy about some finding that the James Webb Telescope has discovered. And there's some talk of some large object
asteroid
moving towards us that's course correcting.
Yeah.
This is the weird part about it. But they're not telling anybody. There's something going on. Do you think they would tell people? Like, imagine if there was a giant chunk of steel, of iron rather, that's headed towards us.
That's a great question. I think the question is, what would we do if we knew?
Do we have the capability of moving that thing? Would the FCC wait 5 months to give Elon
I think you'd probably send as many... But see, it's all a physics problem at that point.
Right. It's also a problem of breaking it up.
Exactly.
If it breaks up, then you have smaller pieces that are hitting everywhere instead of
by the
one
way,
large chunk.
Isn't this like the perfect reason why being multiplanetary just makes a lot of sense?
Sure.
Like for example, would you get on an airplane if they said, "Hey Joe, this is the best airplane in the world. It's the most incredible. It's the most luxurious. It has the best weather. You can surf. But there's only one navigation system, and if it goes out, boop." You'd never do that.
Right.
Would you ever get on that airplane? No.
No.
So, I think we owe it to ourselves to have some redundancy.
Yeah. But ultimately, I always wonder, like the universe sort of has these patterns that force innovation and constantly move towards further and further complexity. And if you were going to have intelligent life that existed on a planet, what better incentive to get this intelligent life to spread to other parts of the planet than to make that planet volatile? Make super volcanoes, earthquakes, solar flares, all sorts of different possibilities, asteroid impacts, all sorts of different possibilities that motivate this thing to spread.
But to say, like, this is fragile,
yeah,
and it's not forever, so create some redundancy. I mean, I was raised Buddhist. I'm not that religious in that way, but I'm kind of weirdly spiritual in this other way, which is I do think the universe is basically, it's littered with answers. You just got to go and find out what the right questions are. So to your point, like, are all these natural phenomena on Earth, the question is, okay, if that's the answer, well, the question is like, do we want to be a single planet species, or do we want to have some built-in redundancy? And, maybe 100 years from now that builds on top of what happens in the next 5, we'll have discovered all kinds of different planets. That's an amazing thing.
Unquestionably.
Unquestionably.
And we also know that there's planets in our immediate vicinity that used to be able to harbor life, like Mars. Right. We know that Mars was covered in water, and Mars had a sustainable atmosphere. Right. So we know that this is not just a dream, that this is possible, that what we're experiencing here on Earth is temporary. And if we get hit by something big, well, we know Earth was hit by a planet in its formation. There was Earth 1 and Earth 2. Right. The formation of the moon, the primary theory is that we were hit by another planet, and that's why we have such a large moon. That's a quarter of the size.
I didn't know that.
Quarter the size of Earth. It's like keeping our atmosphere stable and keeping it's a wild shooting gallery out there. I mean, it really is. And especially our particular solar system has a massive asteroid belt. There's like 900,000 near-Earth objects.
But isn't that so, like, inspiring? Like, this idea of, like, discovering all these other questions that we don't know yet to even ask.
Right.
That is a life well lived.
Yes. Well, that's the most promising aspect to a hyper intelligent AI, in my opinion, that it'll be able to solve problems that are inescapable to us, and also offer us like real hard data about how big of a problem this is and when this needs to be solved by, and then come up with actionable solutions. Sometimes it raises more questions, and one of them was these galaxies that were formed that appeared to have been formed too quickly. Is that safe to say?
Yeah, so we had, one of the reasons we built that telescope was to, what it does, because it can see very distant things, and because light travels at a finite speed, the further out into the universe you look, the further back in time you're looking.
Right.
So because that can see things from which the light has been traveling for over 13 billion years, then you're seeing things as they were in the first billion years or few 100,000 years in the history of the universe, right, essentially. So, a few 100 million years, sorry, I should have said. So you're seeing the first galaxies form with that telescope, which is one of the reasons it was built. And the reason we wanted to see is because we don't fully understand that process. As I mentioned before, we don't really fully understand why they have black holes in them, and it's something to do with their formation, but we don't understand it very well. So it's not surprising to me that when you build that instrument and collect light from the early universe, you see an early universe that's behaving in a different way to the way that you thought it behaved. And so indeed, we're seeing galaxies that formed earlier than you would have predicted. But that means that your model of the way the universe evolved is not quite right, and that's not a surprise, because we wouldn't have built the thing if we'd known everything.
Right, of course.
So I don't think there's any. I think it's fair to say there's nothing there that's absolutely, completely destroys our picture of how the universe evolved from the cosmic microwave background that you saw in those images earlier.
Does it add more complexity? Does it add more nuance?
Yeah, I would say so. And I'm not an expert in that field, but my understanding is that it's interesting because we're having to refine and develop new models of the way that the galaxies formed. And indeed, you're saying that it looks like the stars and the galaxies are present in the universe earlier than we might have expected. So it might be that you're seeing a hint of something really profound that we didn't understand. Or it might be that just the models need a bit of a tweak. So I think
galaxies form quicker than we expected
in
the early stages of the universe. What are those red dots? The red dots that were observed. Do you know what I'm talking about?
In the images, the James Webb images of the early universe. Yeah, they're distant.
That disappeared. Do you know what I'm talking about?
No.
I saved it because I knew that we were going to have to talk about this. It was Jamie. I know we've talked about it before. Yeah, there it goes. Found hundreds of little red dots in the ancient universe. We still don't know what they are. Small galaxies are either crammed with stars or they host gigantic black holes. The data astronomers have collected continues to puzzle them. So, what is that all about? Do you know?
I don't know. It says there that we don't know. So I'm going to go with that. I mean, I think what you're just speed reading that.
So it says
it says a class of galaxies that I suppose we're looking at a kind of galaxy. It seems that we're looking at a kind of galaxy that we don't see today in the universe. Red and compact, visible only during about 1 billion years of cosmic history. So that would be, as I said, because we don't really understand the formation of the galaxies and these supermassive black holes, that's interesting, because what you're seeing in the data is a kind of almost proto-galaxy, I suppose. These little tiny galaxies. That's what it seems to suggest there.
Yeah.
That's the first time I've seen that. But just I think what we're seeing is that we don't understand how structures formed in the universe. We have a reasonable idea, but we don't understand the detail. And the more things like that you find, the more information you have to build models of how stuff formed.
Do we have another, like, next generation James Webb type telescope that's even more efficient or more capable?
There are several sort of proposed observatories, and also, by the way, gravitational wave detectors. So we've got LIGO, which is on the ground. There are proposals to put one in space, which is called LISA. One of the proposals is called LISA, which is lasers between satellites, so you can have much bigger things. And the reason that's interesting is because there'll be gravitational waves from the Big Bang. So, as you mentioned neutrinos, you've got neutrino observatories, which can observe neutrinos from the early universe. And you can see things. It's just like light in a way, but it gives you a different view. You mentioned earlier, it's a different way of looking at the universe. So the neutrinos will have information. Gravitational waves will have detailed information about the Big Bang itself, but we can't detect them at the moment because we can't detect those really tiny little ripples in space and time.
That's what's so fascinating, because if they do launch this and they find new information, that's even more puzzling, and then you keep going further and further and further.
And we want to know. It's like you said earlier, we're asking very deep questions about why the universe is the way it is, in maybe why there's a universe at all, in the sense that did it have a beginning?
Right.
And if so, what does that mean? Was it mean for something like this to begin? Yeah, I find it fascinating, and the most exciting thing of all is that we don't know.